All right, folks, today we're going to start our course in general chemistry. What we're trying to do in this course is we want to start to introduce and differentiate between chemical and physical phenomena. Some of these will be familiar to you, some of these will not. But one of the things that you have to remember as we're starting to explore these phenomena is that it's like learning a new language. We need to learn a new vocabulary and learn how to solve problems and try to put these new concepts into things that we already know. So one of the things that we'll do first is we'll introduce the metric system so we can talk about relative sizes of things. Then we'll finish up with some dimensional analysis. So let's go ahead and talk about our objectives for today. So we want to start by defining matter. We want to differentiate between macroscopic and microscopic systems. And then we want to recall the three states of matter, and then also look at conservation of mass and energy. So it's just going to be a quick overview to see what we remember from previous material. All right, so if we start looking at the background of chemistry, one of the first questions you ask is, what is the material made of? Okay, so the composition is what kinds of atoms and molecules are making this thing up. So composition is what is it made of? Then once we answer the question of what is it made of, we start to look at the properties. So whenever we talk about the properties of something, we're looking at how does this substance behave? So what do we mean by this? Well, it could be boiling point, it could be reactivity, it could be toxicity. And then finally, one of the most interesting things about chemistry is transformation. And whenever we talk about transformation, we're looking at the change of a substance. All right, so what's undergoing this transformation? Well, it's going to be matter. And we define matter as anything that occupies space and displays properties of mass and inertia, which we'll get into more later. So there's two different levels that we start to encounter things in this class. We look at the macroscopic. And so whenever we look at the macroscopic level, what we're talking about is that it's large enough to actually be sensed or measured directly. Okay, and then we'll also look at the microscopic, and we'll even start to talk about the atomic level, and this just means that we're looking at an extremely small level. In the past, maybe we would have had to explore this with imagination, but now as we have instrumentation, we can start to get measurements and then take indirect observations. And even now, some of those observations are direct. But we're going to start to look at things at the atomic level as well. So going back to that macroscopic size, what are the three states of matter? Well, the three states of matter, I'm sure you know, are solid, liquid, and gas. And these are the three that we will explore in this class. I recognize that plasma and Bose-Einstein condensate are also out there, but we're going to focus on solid, liquids, and gases. So how are these different? Well, solids are rigid and they have a definite shape. So a solid, if you have a solid in a container and then you were to take it out of the container, it will still maintain its shape. Even if you turn the container to the side and it falls out on the floor, the solid still maintains its shape. So it has the same volume that it had as whenever it was occupying the container. Now, what about a liquid? Well, a liquid flows, so it's fluid, and here it takes the shape of the container. So if you were to imagine that we had a container right here, so we have our beaker, and then in this beaker we have some water in here. So it has a certain volume to it, but then let's say that something happens and we end up dumping our container over, and now the water is spread out on the floor. So it still has the same volume, But now it's no longer this rigid container. Now the container is the floor. So it will take on the new shape, so that non-beaker shaped. And then our final phase that we'll talk about is a gas. And a gas will take the shape and the volume of the container. So if you were to have an airtight container with pizza, you take it into the room, and then for some reason you open it up, then now all of a sudden that pizza smell will fill up the entire room. It won't just still stay within that container. So it will fill up the entire room and take the shape of the room as well. All right, so now let's go ahead and end with this idea of inertia, energy, and then conservation of mass energy and mass energy. So inertia, as you may recall from physical science, is looking at the tendency of an object at rest to stay at rest. Or an object in motion to stay in motion. So that's one of the criteria that we have to define matter, is matter will display properties of inertia. Another thing that we'll look at, and energy is a really, really tricky concept to define, but we'll come back and explore energy more in depth later as the semester goes. But energy is looking at the capacity of doing work or to supply heat. But energy comes in a number of forms. There's potential energy, there's kinetic energy, there's thermal energy, there's electrical energy, there's chemical energy. But let's go ahead and focus on the two main types here. We're going to look at potential and kinetic. So potential energy, this is the energy, which I'm just going to use an E for energy, that is possessed by an object relative to some reference point. So that is to say that, let's say that we have a mountain here, and then we have two different boulders. We have one boulder that's down on the ground, then another boulder that's towards the top of the mountain. Each one of these boulders, relative to some person standing here, let's say this is our reference point, has a different amount of potential energy. Another type of energy is kinetic energy. And kinetic energy is the energy due to motion. Whenever we look at kinetic energy, sometimes you'll see an equation written for this with Ke equals, or sometimes I'll use T for kinetic energy, but this is equal to 1/2 times your mass times your velocity squared. So m is your mass, and then v is your velocity. And so we'll start to talk more about potential and kinetic energy as we go along. But then finally, one of the last things we want to talk about today is conservation of mass versus conservation of energy. So what does this actually mean? So conservation of mass means that mass cannot be created or destroyed. Meaning that if you were to perform some sort of reaction and you start with 5 grams of reactants, and then you undergo a reaction, then you get products, and then you have some leftover reactants, the total mass will be 5 grams. Okay, so that's conservation of mass. Mass cannot be created or destroyed. There's also conservation of energy, which is saying the same thing except with energy. So if you put some amount of energy in to a system, that energy may change forms, but the total energy will not change. So it just means that energy cannot be created or destroyed. And then there's also conservation of mass energy, which will take the truncated version of this equation, but E equals mc squared. And we'll talk about that more in class.